In the previous videos we have seen that the cost of capital may be drawn from the project rate of return with the following formula. It just suffices to subtract from the AIRR the NPV per unit of invested capital and multiply by 1 plus the first period cost of capital. Evidently, we can also write that the project rate of return, the AIRR, is equal to the cost of capital plus the NPV per unit of capital multiplied by 1 plus the first period cost of capital. Evidently, this only depends on whether we start from the computation of the cost of capital or the computation of the AIRR. It depends on whether we compute independently the project rate of return or the cost of capital. For example, we can start from the project rate of return, take the income, compute the present value of all the incomes, divide by the present value of all the capitals, multiply by 1 plus the first period cost of capital. The NPV is the discounted sum of the cash flows. Suppose that the project is an end period project, so the last cash flow is discounted by n periods, and we have n different costs of capital, so the last factor is 1 plus r of n. And we have a formula for computing the overall cost of capital. We have also called the cost of capital the minimum attractive rate of return. Vice versa, we can start from the overall cost of capital, which is given by the present value of all the market returns that would be generated if the same capital amounts were invested in the market instead of in the project, divided by the present value of the capital amounts, multiplied by 1 plus r of 1, which is the first period cost of capital. And if we start independently from the cost of capital, we can determine the project rate of return. We have a formula for computing the AIRR. Now, as a last issue, we give final framing for computing the AIRR whenever the cost of capital is time varying. And this is a generalization of the formula total return to total capital, which is the definition, the very definition of a rate of return. Total return divided by total capital. We remember that when the cost of capital is constant, what we have is a numerator which is equal to the first income plus the second income discounted by 1 period, the third income discounted by 2 periods, and so on. The last income is discounted by n periods. And the denominator is, as usual, the present value of the capital amounts. Now, if we have time varying cost of capital, so we have a sequence of n cost of capital, the situation is subtly different. We have n incomes. The first income is available at time 1, the second income is available at time 2, the third income is available at time 3. The nth income is available at time n. So we can compute the total return by summing the returns, but when we discount the second income, we discount it back from time 2 to time 1, which means that we have to use the cost of capital from time 1 to time 2, R of 2. Then we discount the third income from time 3 to time 1, so we have to use the second cost of capital and the third cost of capital, and so on. The last income will be discounted from time n to time 1, so we have to use the cost of capital from time 1 to time 2, the cost of capital from time 2 to time 3, and so on, and the cost of capital from time n minus 1 to time n. As for the capital, we have the first capital times 0. Okay, the first capital is at time 0, and the second capital is invested at time 1. The third capital, CF2, is invested at time 3, and so on. And so on. The last capital is invested at time n minus 1. N minus 1. So we have to discount C of 1 from time 1 to time 0, and to this end we will use the first cost of capital. Then we have to discount the third capital, CF2, from time 2 to time 0, so we will use R of 1 and R of 2, and so on until the last capital will be discounted from time n minus 1 to time 0. So we will use R of 1, R of 2, R of 3, and so on, and the last is R of n minus 1. So let us write the whole formula. Let us write the whole formula. We have ARR, a long horizontal line, horizontal bar, first income plus second income discounted from time 2 to time 1, third income discounted from time 3 to time 1, and so on until the last income is discounted from time n to time 1. So we have the product of all these factors. I only write the first factor and the last factor. As for the capital, C0, then we have C of 1 discounted from time 1 to time 0, so we use R of 1. The third capital, C of 2, which is discounted from time 2 to time 0. So this involves only the first two costs of capital, and the last capital is discounted from time n minus 1 to time 0. I only write the first factor and the last factor, which is R 1 plus r of n minus 1. N minus 1. Now, remembering that the income is the product of the single period rate and the capital invested, we can also write the same formula in terms of single period rates. And this becomes a linear combination of holding period rates. So instead of the income, we might write the product of the single period rate and the capital invested at the beginning of that period. So second income, we can replace second income with I of 2 times C of 1 and so on. Third income will be written as I of 3 times C of 2, and the last income may be written as I of n times C of n minus 1. This is an equivalent way of writing the project's rate of return whenever the cost of capital is time varying, and this is mathematically a linear combination of the single period rates of return generated by the project. In terms of our two-period project, I remind that the first income is 375 and the second income is 225. The capital invested at the beginning of the first period is 600 and the capital invested at the beginning of the second period is 400. We assume that the first cost of capital is 15% and the second cost of capital is 30%. And then we can compute the AIRR as total return to total capital, or equivalently as a linear combination of the holding period rates. Now if we use the incomes, we have 375, then we add 225, which we discount by time 2 to time 1. So we have to use the second cost of capital, which holds for investment from time 1 to time 2. So if we want to discount, we have to use 30%. We discount from time 2 to time 1. So we have 1 plus 30%. As for the capital, the first capital is 600. 400 is discounted from time 1 to time 0. So we have to use the first cost of capital. Then we divide by 15% and we get 57.8%. And it should be evident that the same formula is helpful to compute the cost of capital, or AIRR, minimum attractive rate of return. We only have to replace the project income with the market returns. Market returns are rather easy to compute, because if we invested 600 in the market, we would get 15% on that 600. And in the second period, if we invested 400 in the market, we would get 30% on that amount. We discount that amount from time 2 to time 1, so we use 30%. And the total capital is the same, so we would have a project with the same total capital invested but different returns, and the rate of return of this market investment would be 19.2%.